HACCP essentially consists of three elements: prerequisites, flow diagram, and the 7 principles of HACCP. Prerequisites are the standards that have to be in place for HACCP to work, and they include pest control, structure, cleaning, personal hygiene, and supply chain. To start with, we'll focus on pest control. The basic rules to follow for pests are: don't give them shelter, don't give them food or water, look out for signs of pests, and if there are any concerns, take appropriate action. In terms of physical controls, ensure fly killers are near windows and not above food, and ensure bait boxes are not touched or moved. Next, we'll take a look at structure. The basic requirements for structure is that all surfaces are non-toxic, smooth and cleanable, non-porous, in good condition, and prevent pest access. Next, we'll take a look at cleaning.
A detergent is a chemical which removes soil and grease. A disinfectant reduces bacteria to a safe level, but it's not designed to remove soil and grease. A detergent and a disinfectant combined is called a sanitizer.
Dirty surfaces will require several stages of cleaning. First, remove the debris, then use detergent to thoroughly clean down the surface, and finally apply a sanitizer or disinfectant using the correct contact time. Try to clean ready-to-eat areas first before moving to raw areas to avoid cross-contamination. That completes our look at prerequisites. Next, we'll take a look at the flow diagram. A flow diagram is a pictorial representation of all the steps in your food production process. Now let's take a look in detail at the main elements of this video, the 7 principles of HACCP. Step 1 is identify hazards and controls. Hazards could be contamination, such as microbiological, chemical, physical, or allergenic. Hazards could be survival, for example, surviving high temperatures. And hazards could be multiplication, bacteria multiplying and growing. An example of a control would be temperature control. Step 2. Identify critical control points. These are the points in the system that are essential for food safety. If they are controlled, the food will be safe to eat. An example of a CCP is cooking the food. 3. Establish critical limits. This is the line between safe and unsafe. An example of a critical limit is 75 degrees C as a cooking temperature. Number 4. Monitoring the CCP. An example of monitoring is probing the food. 5 is corrective action, for example, cooking it some more. Number 6. Verification. How do we know the system is working? Well, if no one's getting food poisoning, it's a good indicator the system's working. And the last principle, record keeping, writing down temperatures, etc. Let's look in more detail at principle 1, identify hazards and controls. As we said, hazards can be contamination, multiplication and survival. So let's start with contamination, and examples include microbiological, chemical, physical and allergenic. We'll focus on microbiological. Examples include bacteria, viruses, molds, yeast, enzymes and protozoa. We're going to focus on bacteria. There are essentially 3 different types of bacteria. We can think of them as the good, the bad and the ugly. The good are harmless or useful bacteria, bad are the pathogenic, and ugly are the spoilage bacteria that make food go off. We'll focus on the bad ones, pathogenic bacteria that can make you ill.
So, where do pathogenic bacteria come from? The main examples are raw meat and poultry, eggs, pests, pets, soil and dirt, and people. Direct cross-contamination occurs when raw food is touching or drips onto ready-to-eat food. One source of bacteria is animals. During his break, our chef Simon played with a dog and went back into the kitchen without washing his hands. Bacteria was transferred via his hands and clothes. Oh dear. EHO also saw Simon using the same chopping board and knife for raw and ready-to-eat food. He also touched raw chicken and didn't wash his hands before touching sandwiches. At a contract catering site, one member of staff was preparing sandwiches. Stephanie suffers from eczema and didn't tell her line manager. The sandwiches were stored in a fridge that wasn't holding temperature. And this resulted in food poisoning.
Next we'll take a look at multiplication. Some bacteria need only very small numbers, hundreds, to cause illness, therefore it's vital to prevent all contamination. Some bacteria need to multiply in large numbers, millions, to cause illness. It is vital to deny bacterial conditions for growth. What are the conditions for bacterial growth? Think TT, MNN and AP. T stands for time, T stands for temperature, moisture, nutrients, atmosphere and pH. Time. Bacteria double in number every 10 to 20 minutes and this is known as binary fission. Temperature. The danger zone is between 5 and 63 degrees C. Moisture is available water for the bacteria. Nutrients. High-risk foods have the right proteins for bacterial growth. We also think in terms of raw foods, which are generally a source of bacteria, and low-risk foods on which bacteria can't easily grow, but we do need to prevent contamination. Atmosphere. Aerobes require oxygen, anaerobes live without oxygen. And pH, acid levels. Think pickling. Conditions for bacterial growth. Let's focus on temperature. At -18, bacteria lies dormant, it's asleep. At 0 to 5 degrees it grows slowly. 20 to 50 degrees it multiplies rapidly. 63 degrees the bacteria starts to die. 75 degrees pathogens are destroyed, and at 100 degrees all bacteria die. Let's focus now on survival. Firstly, to ensure bacteria can't survive, we need to cook it to the correct temperature.
Our chef sanitised the probe before checking the temperature of the turkey. She also inserted the probe deep into the meat to obtain the core temperature, which was 75 degrees. Remember, the turkey was potentially a source of different types of bacteria. Cooking to 75 degrees for 30 seconds kills bacteria. However, some bacteria can form spores. It puts on a protective suit to protect itself during adverse conditions such as high temperatures or lack of moisture. And when the conditions return to normal, the bacteria removes its suit and starts to multiply again.
So those are our three hazards from Principle 1: contamination, multiplication and survival. Now let's take a look at controls. Controls will include temperature controls such as cooking or cold temperatures of the fridge. It stops it growing. Correct fridge layout to prevent contamination, colour coding, stock rotation and personal hygiene. They're all there to prevent hazards of contamination, multiplication and survival. Number 2. Identify critical control points. It's a step in the process where control is essential to prevent or eliminate a food safety hazard or reduce it to an acceptable level. In other words, it's the steps in the process at which, if you control them, the food is safe. Principle number 3 is establish critical limits. A critical limit is the line between safe and unsafe. Most companies have a critical limit and a target. A target is a control criteria more stringent than critical limits. So for example, frozen deliveries, the critical limit might be minus 13 degrees, but the target, what you're aiming for, is minus 18. Fridge temperatures, the absolute limit is 8 degrees, but the target, what you're aiming for, is 5 degrees. And cooking temperatures, critical limit 75 degrees, but some companies might have a target of 82 degrees. Number 4, monitoring. The planned observation and measurements to control parameters to confirm the process is under control and critical limits are not exceeded. In other words, it's how we measure. Examples are checking delivery dates, checking delivery temperatures, observing practices, checking dates in fridges, and probing food. Principle 5. Establish corrective actions. Corrective action is the action you take when a critical limit is breached. Remedial action should be taken before the critical limit is breached. Corrective action should bring the CCP back under control and also deal with the affected product. In other words, it's what we do when things go wrong to ensure the CCP is under control and we deal with the product. Examples include refusing a delivery at 10 degrees or anything above 8, disposing of out-of-date food, and continuing cooking until food reaches 75 degrees. Principle number 6. Establish verification procedures. How do we know the system is working? These are the methods, procedures, tests and other evaluations in addition to monitoring to establish if the HACCP system is functioning as planned. In other words, how do we know it's working? Examples include audits, laboratory testing of food, tracking number of complaints and tracking frequency of food poisoning. We're going to focus now on food poisoning. Bacteria cause food poisoning. There are 3 types of bacteria, and it's the pathogenic bacteria that cause illness either through intoxication or invasiveness. An example of invasiveness would be Salmonella. The bacteria invades the body, works through the digestive tract, and attempts to invade our entire body. Our body's response to damaging the cell walls is to produce diarrhea to flush out the invaders. Intoxication are bacteria that produce toxins, poisons, which cause illness. Exotoxin, the bacteria excretes the toxin is already on the food. Endotoxin, the toxin is released at the end of the bacteria's life. It's released when the bacterial cell wall breaks down. Neurotoxin affects the nervous system. And enterotoxin, it's already on the food but it doesn't affect the body until it reaches the digestive tract.
Besides bacteria, there are other causes of food poisoning.
Viruses.
Poisonous plants such as rhubarb leaves. Poisonous fish. Metals. Chemicals. What are the symptoms of food poisoning?
The main symptoms of food poisoning are vomiting, diarrhea and stomach pain. A particular concern are vulnerable groups. These are the groups of people more likely to be susceptible to food poisoning, and they include the elderly, the pregnant, the newborn, and those who are immunocompromised or already ill. Principle 7 is established documentation, the records we complete. Examples of documentation include prerequisite programs detailing your procedures on personal hygiene, pest control, etc. HACCP, which we've just been discussing. Temperature controls, temperature records detailing your delivery temperatures, fridge temperatures, cooking temperatures, etc. and training records. We've now completed the 7 principles of HACCP. What are the consequences of poor food safety or failure to implement HACCP? Examples include poor reputation, prosecution, fines, and potentially imprisonment. Who instigates a prosecution? EHO do. What other powers do EHO have? They can enter the business any reasonable time, that's any time you're open. They can take informal action such as verbal advice or letters. They can take formal action such as improvement notices or emergency prohibition notices. They can close down the premises. They can instigate a prosecution and they can seize food and records. How do we manage food safety? We provide effective training and we adopt a coaching approach. We lead by example, we conduct thorough internal audits, we investigate any complaints, and we provide adequate resources. For further free resources, please visit the website 5-Star Pathways. Look up food safety free resources. To book food safety training courses, visit hygiene.org.